All right. So our group decided to analyze the data that was provided in the project outlines. It was titled public transportation. It was that set of data, and along with that set of data, we got these three Excel sheets. Um, and instead of importing those Excel sheets into MATLAB with an XLS read in the actual project code, I decided to save uh, those variables as or save that data as a .mat file, so that when other people were to run this function, it would save time. Um, I saved them. I did the XLS read on each of them and saved them under this file here called big data, which consists of each one of those Excel sheets. Um, so all the data is there, but it was just a way to bypass load times. Then what this main here does is essentially it does everything in our script that our script's capable of in one spot. Um, it takes in, it starts assigning variable names to those rows of data in the larger file or the larger sets of data. And then, as you can see here in these Excel sheets, um, when you look at the station numbers, the range is only from about 1 to 52. But when you look at the locations, that actually goes to 145. So the first thing we did was we created a variable named stat_n here. And that is an array of locations, location numbers or station numbers, sorry, that are actually included in the data sets. So it eliminates any of the other stations that don't have like the larger portions of data on them or about available. So you can demonstrate that by running this portion of it. And we're left with this variable here. It is an array containing station IDs that are included in both or in all three sets of the data. It excludes any of the other station numbers or IDs that again aren't in the larger sets. Um, it essentially it takes all of the station ID, that entire column, reorders them, and then whenever the station ID, let's look at reorder real quick. Whenever this number changes, let's say from 3 to 4, it'll log 3 and then it'll move on to 4. So whenever it does not equal, whenever this, let's say this position does not equal this position in the array, then it'll log the previous position as a station in our new variable. And because when we get to the very end, we won't be able to define, or we won't be able to compare our very last station to anything further, we created this new variable and went ahead and took and just automatically included the last station ID. And that gives us an output of station N. And then we move on to just identifying the average number of empty bikes for every station, and then we take and compare those the average number to the critical point, which we defined as 75%. So if the average number of empty bikes is greater than or equal to 75% of that station's entire capacity, then it's logged under this variable need station. And the same thing goes for the remove station. So if the average number of bikes that are available this time instead of the average number of bikes that are unavailable is greater than or equal to 75%, then it stores them under this variable here. So let's say the average number of bikes available at station J is 10, and the average capacity of station J is 12 bikes, then station J on average has more than 75% of its bikes available, which identified to us that that station is underused, and that then it would be flagged as remove station. Then we just go on to doing the average date of birth. Average date of birth, which was subtracted from 2016, so it gives us the actual years of age, which is saved under the variable name years old. And then for the map, we had to take and compare, we had to use the strings involved in the XLS read as well as the numeric values. And in order to create a set of data that contained only the actual station IDs, but all of the other stuff, that's what this block of code's doing here. So it's using our stat n, our station n variable that we created earlier. It's reading the data from the XLS sheet, and it's creating a variable that we named f lock, so like final location is what I was thinking when I named it. So go ahead and run main, and I'm going to close the GUI for now so that we can take a look at this variable. So it's pretty much the entire Excel sheet for the locations, but it only contains the number. It doesn't contain any location that isn't included in the other data sheets. And then we go ahead and we create a web map. In this function here, the map, where are you, map of all. So all of this was included in our main file, and then from that point we use this function here to create a map of pretty much the immediate area, which can be seen here. It's a web map code. You got to have the map add-on, the map pack add-on or mapping tool add-on for MATLAB. And then we create unique layers to that map, all including a station ID and the details of like the streets. And those are all printed out through this function or this set of code here, this loop. And if we go to the GUI, I can walk through that really quick. So again, this is the map. It gives us all of the data points. When I click on this, it takes a minute to load it because it's going to load each point as a layer. And pretty sure we have to let that continue. I can't move on to a different portion or else it'll interrupt it. So we'll just let that load really quick. All right, when you click on a specific point, it gives you the station ID number, and it gives you a street identifier. So if we were to zoom in on this location, we see it's at Cambridge Street and Brigton Avenue. So it's in Union Square at Brigton Avenue and Cambridge Street. So we say, okay, well, that's the place we're going to be tomorrow, and we plan on using this service, these bikes, but we want to know how many bikes there are going to be available. Maybe we should plan on using, maybe, I don't know, maybe we plan on driving or getting a taxi or something. So we can use our function, and again, really quick, it was station number 8. So we put in that station number, and we hit calculate. And we can see that the average number of bikes at this station is only 2. So the average number of bikes available is 13% of that station's capacity. So that station almost never has any bikes available. So that's what we're calculating there. So we better make other plans. Maybe we can look at another nearby station, say station number 37. And this one has better odds of finding a bike. This one has on average 8 bikes available. And the other functions of our code, we can calculate the average age of riders. Again, this is in years, so they're average 40-year-olds. Then by using that script that we seen earlier, we can calculate which stations need a larger bike capacity. So what that means is that on average 75% of that entire location's bikes are unavailable. So that place needs bigger capacity. We can look at those locations on a map. And then we can calculate the stations that are rarely ever used, so they have over 75% of their capacity. And we can look at those and their locations. It's quite ironic, but what this could tell us, we could say is like, well, this station here is one of the stations that needed more bikes, and this one is one that needs to be removed. So we could quite literally take the station's bikes, so like station number 45, and add that capacity over here to station number 33 and produce better, I don't know, maybe better business that way. And other than that, I don't really know what to explain, and I'm sure I've dragged on for quite a long time. So that's our project. Thank you.